Hello students, welcome back. In this video, we are going to do few questions based on the previous video. In previous video, we learned how to find the domain of the function when function is given to us in the form of a formula. So let's start with the question. So few cases I discussed in the previous video. If you haven't seen that video, you can go through. I've shared a link in the description. So let's start this question. The question says find the largest possible domain of the following function. So case by case I have discussed in the previous video. So first one is fx is equals to 3 minus 6x. So this is the first case. So first case says when fx is given to us in the form of a polynomial. In that case, domain of a function is equals to set of real numbers. So that means first part is already done. It's very simple because 3 minus 6x is a polynomial. So fx is given to us in the form of a polynomial. So that means the first one's domain is the set of real numbers. Now second one. Second is gx. Gx is given to us in the form of a by b. That is the second case 7 by 3 minus 6x. This is a fractional function or a rational function. So here for this one we learnt domain of a function. We learnt this thing. The domain of a function is equals to real number minus solution of b. So for that we have to find the solution of b. So how to find solution of b? So what is b here? This is a by b form. So from here we can see b is 3 minus 6x. b is 3 minus 6x. So how to find the solution of b? We can equate b with 0. So 3 minus 6x is equals to 0. We can equate b with 0 and we can find the value of x. Value of x means solution of b. So first of all 3, let's shift to other side. So minus 6x is equals to negative 3 because this is positive. When we shift to other side it becomes negative. So x is equals to negative 3 by negative 6 because 6 here it's getting multiplied. When we shift it will get divided. So negative and negative signs will get cancelled. 3 into 1, 3 into 2. So we got the value of x as 1 by 2. So what is the domain of this function? That means domain of the given function is equals to real numbers minus 1 by 2. This is the domain or the required domain or the largest possible domain of the function gx. Let's do the third part now. So third part, function is given to us as hx square root of 3 minus 6x. So these type of functions, how to do? We have to write 3 minus 6x, the number which is written inside the root. We have to write that particular expression greater than equals to 0. We have to write that particular expression which is written inside the root that is equal or greater than 0. So now we can solve this inequation. So for inequation different rules are there. So rules where I have described rules how to solve inequations. I have made a separate video. I'll share that link in the description. You can go through. So here I am just going to solve this one. So 3 will shift to other side. So I am left with negative 6x is greater than equals to negative 3. So positive 3 when we shift to other side it will become negative 3. Now I have to shift negative 6 to other side. When negative 6 I am shifting to other side, especially in case of inequations, you have to remember when the negative number is there with the variable and when you are shifting it to other side, or basically directly also we can do this way by transposition like normal linear equation. I am not going to explain, with negative 6x, I'm just dividing both the sides. So in that case, for inequations, what you have to do, you have to reverse the sign of inequality. Whenever you are multiplying the inequation or dividing the inequation with negative number, you have to change the inequality sign. So that's what I have done, because with negative 6 I am dividing. So negative 6 and negative 6 will get cancelled. So here I'll get 1 by 2. So x is less than equals to 1 by 2. X is less than equals to 1 by 2 is the domain of this function. So we can write domain of the third one. Domain of the third one. So x belongs to, we can write x belongs to, x is less than. So less than means it will go till negative infinity to 1 by 2. So 1 by 2 to negative. This way we can write. Or you can also write it in this way only. X is less than equals to 1 by 2. So this is domain of the given function. So let's do now fourth one. Fourth one, function is given to us in the form of kx. So kx is equals to log of 3 minus 6x. So whenever logarithm is there, expression which is written with logarithm 3 minus 6x, that we have to write greater than 0, only greater than 0, and the solution of this is the domain of the function. The solution of this is the domain of the function. So this is an inequation. Again we have to simplify. So first of all, negative 3, positive 3, when we shift to other side it will become negative 3. So negative 6x is greater than negative 3. Again we'll divide this with negative 6. So when we are dividing the inequation with a negative number, dividing or multiplying, we have to change the inequality. We have to change the inequality. So negative 6 and negative 6 is getting cancelled. So x is less than, here if we do cancellation, 1 by 2. So x is less than 1 by 2. So domain of the function is x is less than 1 by 2, or you can write it in the form of interval also, that x belongs to, see, it's not equal, only less than. So that means I have to write 1 by 2 with open bracket and it goes still. So it's less. It's less. So that means negative infinity and here 1 by 2. So this way also we can write. Let's do one more question, similar kind of question. So same 4 cases, we have to find the largest possible domain as we did in this question. So those cases we have to see. Fx is equals to x square minus 4. This is the simple polynomial function. So for this one we can write here domain of this function is equals to set of real numbers. For polynomials, the domain of the function is a set of real numbers. Now let's find domain of gx. So gx is a by b form. So a by b. So here we have, first of all we have to find the roots of b. That means solution we have to find. Here b is x square minus 4. X square minus 4. So we will equate b with 0 and find the roots of the equation. So x square minus 4 is equals to 0. We have to equate b with 0. Now this is quadratic equation. I can write it as x square minus 2 square. I can write it as x square minus 2 square because 2 square is 4. So this I can use algebraic identity. So a square minus b square, we know it is a plus b into a minus b. Here a is x and b is 2. A is x and b is 2. So a square minus b square is a plus b into a minus b. This is equals to 0. Now quadratic equation, whenever we are solving, we'll write these factors. We can write either x plus 2 is equals to 0 or x minus 2 is equals to 0. From here, I'll get two values of x. X is equals to negative 2 or x is equals to positive 2. So I found the roots of the equation. This was a quadratic equation. More we will learn while doing quadratic functions, how to solve. So everything we can learn there. So now what is the domain of this function? So domain of this function is equals to r minus the roots of b. Roots of b are what? Minus 2 and plus 2. So this is the domain of second function. So domain of this one is equals to r minus negative 2 and positive 2. This is the positive 2 we can write as 2 also. So this is the domain of second function. Now let's do the third one. In third one, hx function is given to us. So the function is given in the form of a root. Whenever such functions are given, so the number which is written inside the root here x square minus 4 is written. That we will write greater than equals to 0. Greater than equals to 0. So domain of this function is actually the roots of this equation, roots of this inequation. So we have already found the factors. So x minus 2 times x plus 2 we can write. So like we did in the previous part, same way by factorization we can get the values. So this is greater than equals to. In previous question it was only equals to, now it is greater than equals to. So I can write same way, x minus 2 is greater than equals to 0, or x plus 2 is greater than equals to 0. So from here we'll get x is greater than equals to 0, and here no, x is greater than equals to 2, because 2 we are shifting to other side. So negative 2 will become positive 2. So here we'll shift positive 2 to other side to become x is greater than equals to negative 2. So we can combine. Whenever inequation we are finding, we have to combine. On combining, I'll get the value. So x is less than. So this means, so x is greater than equals to 1 second. So here we have done x is greater than equals to 0 and x is greater than equals to. So here we got x is greater than equals to 2, or x is greater than equals to minus 2. So two values we are getting here. So how to write now? Because or is there. Or is there. So in case of or, because domain of this function, we know domain of this function is equals to solution of a greater than equals to 0, or root of a greater than equals to 0. Now how to find root? So two values of x from number line we can understand this in a very better way. See, this is a number line, or you can say x-axis. This is 0, 1, 2, and this one is negative 1, negative 2. So first point says x is greater than 2. X is greater than 2 means we have to start. There is equality also. It's starting from this point and till infinity it is going. It keeps on increasing. The second one, it is saying x is greater than equals to minus 2. So second one, here we can see from here it is starting and it is greater than equals to minus 2. So this point is also included here. So now we have to find in case of or. In case of or, everything we have to include. Everything we have to include. So everything you can see here. Everything means green part as well as the part which is shared by both. So when I have to write its domain if I can only write as x is greater than equals to minus 2, because this line covers everything. This line covers this part also. You can see here this line covers x is greater than equals to 2 also. Here I have shown you, I have drawn and I have shown you. So that's why if we write this one, that is also the domain of this function. So we can write domain of this function is equals to x is greater than equals to minus 2. Or you can also write it in the form of an interval that x belongs to minus 2 to infinity. Now let's do the last one. Let's do last one. K1. So function k is given to us. function k is given to us. K is equal to us in the form of logarithm. So fourth rule we have to use here. So whenever function is given to us in the form of logarithm, the expression which is written with log, that we have to write. So x square minus 4 is greater than 0, only greater than 0. So when I solve this one, so same way I'll get now x minus 2 times x plus 2. This is greater than 0. So I'll get x minus 2 greater than 0 or x plus 2 greater than 0. So from here I'll get x is greater than 2 or x is greater than negative 2. So this, when we are shifting to other side, negative 2 will be changed to positive 2 and positive 2 will be changed to negative 2. So we have found now the solutions. Now we have to only combine and we have to see again. If I draw number line here, if I draw x-axis, not number line, you can say x-axis, because on x-axis I have to see. So this is 0, this is 1, this is 2, 3 up to so on. This is negative 1, negative 2, negative 3. So x is greater than 2. X is greater than 2 means my graph is starting from here. So 2 is not included. It's not included. So it's just starting from here, but this part is not included. And then x is greater than negative 2. So x is greater than negative 2 means again negative 2 is not included. So it's starting from, so like this. So here you can see I have drawn the graph of these two lines. I've drawn the graph of these two lines. But here or means everything I have to take. Or means everything. But here in x is greater than negative 2, this 2 point is also coming, whereas in this line 2 is not included. This means not included. Here 2 is not included. So in such cases, how we will write? How we will write the solution set? I'll tell you. We'll write this way. X belongs to. We'll write x belongs to. So first one is, we'll write negative 2. So open brackets we will write, not closed one. We'll write negative 2 to 2. This part we'll write with open brackets. Then union. Then 2 to, now it keeps on going, infinity we can write. So this is the solution set of the this type of functions. So here domain of this function we can write now. Domain is equals to x belongs to negative 2 to 2 union 2 to infinity. So this means this 2 we are not including. It starts from here. Minus 2 is also not included here. So it goes from minus 2 to 2. So both minus 2 and 2 they are not included. Then again 2 to infinity. So this is how we will write. So thank you so much for watching the video. I hope to see you in my next one.